Good afternoon, I think. Let me double check things. Yeah, that's right. Seems to be live. Welcome, Darling Ducking. Oh, I like it. Good name. Darling Ducking. Let me just organise some bits here on the left. On the other screen. So, what have we been doing? We've been working through, well, a combination of things. I've been, when I faced a mic, that probably works, doesn't it? We've been working through this, and also on different days we've been teaching more basic stuff for Haskell. So the basic stuff's for other people to learn, and this stuff is for me to learn, or comma, or not comma, / struggle. Yeah, it's kind of different. I'm grasping most of it, to be honest. I have done it, but it's more going over it and redoing it, and I want to fully understand it rather than just doing bits and pieces. And because it's sometimes it's different from using it to actually fully understanding what's going on underneath the hood per se. So we finished off with doing, what was this one? Chapter 5, which was constraints. What was it called? Constraints and gadgets. So yes, we had a little play with gadgets. We kind of then, the latter half of that was lists. So we had like our own list type, and then we basically created our own type family, and then we made our own ORD and show instances for that. And I think ultimately what happened is we demonstrated the beginning. So we started with a H list, which was like this. That's the first one. Then we made a data family. A type family. Further down like that. And then because that was constrained to EQ, if you look specifically to EQ, and then we made another type family which didn't have a constraint to anything. So then we could just pass on this. Hold on, I think the audio of the music is a little bit loud. Yeah, so then we were able to use a function which took a type and returned a constraint. Let me have a sip. I've got a bit of a dry throat already. You can sometimes tell when someone has a dry throat, because it comes goes. You get a little that horrible clicking sound. I don't like that clicking sound. I'm probably gonna. That's it now. You're gonna spot it every time I speak. Yeah, and we had to implement. Actually, let's go back and have a little look at that. Chapter 5. There we go. And we had to implement our own, which was so there was the type family. Hold on, let me make that like that. I think that's big enough. Let me double check. Yeah, that seems big enough. Yeah, so we created our own type family. I think I had a question which confused me. I can't remember what it is now. Can't recall. I think it might be in chapter 2. Yeah, and then we were able to create an instance. And then we worked out that, because before, because if you look at how hey, Super PP, how's it going? We worked out, what did we work out before? Oh yeah, so we worked out that we could do it like this. So we passed the EQ. So if you look at all, that takes a function and then the type or the list of types. So in our scenario, it'd be, we constrain our instance of all, hold on a second, LD, let's just shut that, because the docs are really handy, but they're not when you're in here, because it just shows up a bunch of stuff which we don't need to see. So you're able to do that, and I just assumed for some reason you could do exactly the same with ORD. So you can just use the constraint of all ORD TS, but because of the type or the class of ORD, there's actually already a constraint of EQ. So then that's probably why I assume we'd need the EQ here. That'd be my guess. And it seems, yeah, it works. So let's assume that. And then we moved on to, we started doing ranking types. And what was the idea behind that? Just have a little, yes. So it was implicit quantification. Oh, well, first, I didn't quite understand what that was, the actual meaning. Oh, hey, Leo, how's it going? Yeah. Well, we went through You were here, Leo was here to the bitter end, struggling with me. Or were you? I think you were. Oh, I'm having like weird deja vu. Let's pretend you were, and then that makes me feel better. Yeah, so we were kind of like working out the fact that it's all about the call site of specific things, and then if you'd assume that if you wanted to like pass apply 5 ID, you could just take A to A without the for all, and then you constrain you'd put the for all prior right here, but then that fails. So the idea being is it's wherever, if you were to do a for all here, well, the A that you're actually passing on isn't actually passed on to this A. Sorry, a boo would be RF. Should we call that F or something? Yes, I stayed until the very end yesterday. Got a nasty headache today, though. Probably not staying long today. So have I, but oh man, sorry you got a headache. Is it from yesterday? Because I think that's when I've got mine from. Let me just do something here. So there we go. Yeah, I still haven't fixed my MacBook Pro. That's why I've got music, because you can hear that. And I can't really, unless I put my Mac into a box or something, I can't really do much about that, which is annoying. Yeah, just, I don't know why. It's I'm using, what am I using? Wirecast. And yeah, it just eats up all the CPU. Check this out. I'm going to show you. Activity, monitor, Wirecast, 115% CPU. Wicked. 123% CPU. I like how you can go above 100% in CPU. So you're using this magical percentage that doesn't exist. Because you'd think 100% is the whole of something. Whatever. Yeah, so it's always right up there. And then when you actually check, the Wirecast has its own little tool that shows you how much CPU. And then that lies to us and tells us that it's using like 15. So, gives, eh? So because it's 120 odd, the laptop moans a lot. And then secondly, things start to slow down after around the 2 hour mark. I'm abusing my laptop to death, but stuff it, you know. That's what happens. I blame Apple. Just blame Apple for everything. That's what I do nowadays. Yes, so we were looking at that. We got, yeah, so this is that part. And then we create the language, not language constraint. Oh my god. Yeah, so we put the rank end types up here. So it allows us to introduce, and then we kind of we got to this, and we did that, and I think we stopped around here, was my thinking. Oh, and we started explaining the rank, so the rank of something, and rank was how much things, well, does it explain a little bit? Maybe we could catch up on that. Yeah, so the intuition behind high rank types is that they are functions which take callbacks. Yeah. So the rank of a function is how often controls gets handed off. A rank 2 function will call a polymorphic function for you, whilst a rank 3 function will run the callback, which itself runs a callback. So it's almost like nested functions in a way. But so it says that this is just a rank 1 because it's just doing an A to A. But this is a rank 2 because we're using this function in here. And I'd assume if that was also to have a similar vibe to this, then this function would be rank 3. And if there would be another nested rank 4. Yes, I guess that's what's happening with the ranks. Yeah. Because the callbacks are used to transfer control from called functions back to its calling context, there's a sort of a seesaw thing going on. Okay, so for example, consider this. So there's a foo for all. Oh, did we copy that? No, we didn't. Let's do it. Oh, as a caller of foo. So we've got foo for all R, for all A. So that's like another function it's taking. And it's returning to R. So as the caller of foo, we are responsible for determining that instantiation of R. Oh, hey Vlad, how's it going? Thanks for the party. We're having a party. I hope you're alright, mate. I didn't watch the end. What did I do? I was trying to fix this bleeding computer. Hey, Control. I like that name, Control Delete. It's a good name. Thanks for the follow. Yeah, I was talking about rank n types. Is that what we're calling it? It is rank n types, I think. Oh, it's right up there. Yeah, rank n types. So we're going over that in this book called Thinking with Types, and that's what we're doing. We're thinking with the types, and we're trying to think as to what's happening where. Yeah. So we're working out what a rank is of something. You know, the word rank in English is actually like, well, it's got double meanings. You know, when something's rank, it's like horrible, isn't it? It's like it's a bit of a slang in English. Hey man, that's rank. And it's like, yeah, that just keeps popping up in my head every time I say rank. I don't think rank as in the army rank. You're of sergeant rank. I'm thinking this stinks, which doesn't help at all. Yeah, so blah blah blah. So let's recall its definition of apply to 5, which we've got. Yeah, so we've got that applied to 5. How we change it for it to work, and then this is where it fails. So notice that the implementation of apply to 5 is what calls F. Yeah, so here we're calling F, and what we're imagining is that F is basically, well, we can, okay, yeah. So the F would be a boo you're passing on. The problem is you can't, because we're pretending that this is just like an ID, we can't determine by doing this, because you'd imagine that you'd be able to do it like this. So you'd think it'd be like that, but then it fails, because at that point we're instantiating the A from within this, or whoever calls this function is going to instantiate that A, or give it a type. And then if we look at an example, func2 is doing that, but that can't give you an A at all because we're just passing along a function. So for that reason, it's almost like the for all is going the wrong way. We need to be able to pass the A to this function, which is actually boo, which is in then itself is relevant here. So it's because of where it's a call site and a callee. So to get around this, ultimately you just put the for all in here. Oops, A, like that, and then that works. And then you've got the ability to instantiate the 5 to F, which is directly passed into here, and then the A knows that this is int to int. Clever stuff. So yeah, I think this was what it's talking about here. Oh no, it's talking about the rank of it. Yeah, so it's going to say that this is a rank 2, because the implementation of apply 5 is what calls F, because F is rank 1 here. Apply to 5 can instantiate it at int. Compare it with the broken implementation. Yeah, here F is of rank 0 because it is no longer polymorphic. So leaving it like that still leaves it to rank 1, but when you have it with it's broken, because obviously imagining that it would work, but it can't obviously, then that becomes rank 0. Okay. The caller of apply to 5 has already instantiated A by the time apply to 5 gets access to it. Okay, so at this level here, that's where it wants. If it's before, that's exactly where it wants the type to be applied, but it can't, hence it fails. And that's what makes it a rank 0, because you're not passing on anything. Okay. The caller of apply to 5 has already instantiated, blah, 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 gets access to it, and as such, it's an error to apply it to 5. We have no guarantees that a caller decided A to be int. So yeah, so around, if you have that on the left, then you've got no, the compiler can't ever tell that, does this want to be, it can't tell the type is, well, can it instantiate that this is going to be an int? No, it can't. You're leaving it to the call, which is bad. So we have no guarantees that the caller decided A is equal to int. by pushing up the rank of apply to 5, we can delay who gets to decide the type A. Ah, so it's like, I guess that's a better terminology, delay. Yeah, it's almost like I kind of think of it as it being pushed around in a way, and then where the call site is, but I guess delay is potentially better. And where was I? Higher rank from being seesaw. Oh, okay, so even higher yet ranked. Where's delay? Apply can delay who gets to decide a type A. We move it from being a caller's choice to being a callee's choice. Yes, that makes sense. So the callee is here. So we give it the choice right here because we have that in there. So then when we grab the A, we're just passing it along. Yeah, okay. Even higher yet ranks also work in this fashion. The caller of the function and the implementations seesaw between who is responsible for instantiating the polymorphic types. We will look more deeply at these sort of functions later. Okay, cool. I mean, yeah, I think we're maybe going through that for about a good 40 minutes yesterday, and it made absolutely, well, it made sense, but it just, I don't know, things were just going around in my head wrongly. It's all about instantiation of this A is what's key here, but I think we get more examples. It is valuable to formalize, spelt wrong with an S. Oh no, not if you're American, sorry. I saw it, someone was doing something and they were reading it, and then I can't remember. Anyway, don't know what I'm on about. Okay, so valuable to formalize. It is valuable to formalize exactly what's going on with this rank stuff. Okay, more precisely, a function gains a higher rank every time a for all quantifier exists on the left-hand side of the function arrow. Okay, so there, I guess, but aren't for all quantifiers always on the left-hand side of the function arrow? Yeah, that's a good question. They should be, shouldn't they? I guess maybe. Oh, well, we're going to find out. Read on. I've learned from doing this. Stop trying to work something out. Read on, because it probably gives you the answer. I've been doing that wrong very much, that's wrong also. That's definitely not grammatically correct. But aren't for all on the left side of the function arrow. While it might seem that way, this is merely a quirk of Haskell syntax, because the for all quantifier binds more loosely than the arrow type, the everyday type of ID. So it's more loosely than the arrow type. Oh, okay. So for all a dot a to a has some implicit parentheses when written in full. Oh, okay. Like that. It's easier to see the arrow. It's easier to see that the arrow is in fact captured by the for all compared to a rank n type with its for all its implicit parentheses inserted. So here, for all R, for all A. Okay. So it's just showing us how. So that would be, that's, okay, yeah, that makes sense. That's with an R though. So we've got two for all here. Here we can see that indeed the for all A is to the left of the function arrow. The outermost one, and so the rank of the function is simply the number of arrows its deepest for all is to the left of. So does that make it a rank 2? You'd imagine. You'd think so, wouldn't you? Because that's rank 1, and then another one's rank 2. Here we can see that indeed the for all A is to the left of the function arrow. Okay, it's to the left. The outermost one, and so the rank of the function is simply the number of arrows its deepest for all is to the left of. Deepest for all is a number of arrows. Is it? R2? I don't know. It's a little bit confusing. Let's find out. What is the explicit rank of int? Try adding parentheses. Okay, we'll do that. We'll comment it out first. So it's like this, isn't it? Except I've just put haven't copied the I. So you'd think that's just rank 1. It'd be my idea. I'd say that's rank 1. What I'll do is we'll double check them because I'm not 100%. This one. 1. I'm with you. Oh, hi again, ting ting thong. I'm not reading. You're going with 1 as well. Hi, Haskell. Yeah. Okay, I'm with you. Let's do it. I'm going to say you're right because I don't have a clue. But it feels like it. Oh, what's happened to... It's like, this is what happens when you copy and paste. Stop being so lazy. It's your own fault. Especially then you just... Okay, so that one... so you'd assume... That's going to be 2. Be my guess. Rank 2? I'm going to go for 2. Rank 2. Because I'm figuring it's like... oh no, hold on. C. Oh. Maybe, because it feels like whatever's to the right of the 4 all. It's the number of arrows. Oh, I don't know. Yup. Okay. That's good for me. Next one. So this one, right associativity. Oh, hold on. Oh, it's just part of it. Okay. Hint recorded, function arrow. Oh, we're meant to like try and do some of this, aren't we? Right associativity. Okay. So that'd be my guess. Okay. Feels like I'm just getting a bit lucky, but let's have a look. The next one. We don't know yet. That's going to be of rank. Oh, and that is, let's have a look. So it's oh my goodness, look at this beast. I'm going to guess 1, 2, 3. I'm going to say rank 3, but that's just me having a... Is it MX? Yep. ZMX? Yep. I'd say 3. Why? I don't feel like I'm doing this right at all. I just feel like I'm counting the arrows to the right of the 4 all, which feels like it's potentially wrong. Okay, I'm going to go for 3. But what we're going to do now, because I didn't realise, it's just there's answers at the back. So what page are we on? 79. Let's go right down. Is there the answers here? Look at this. Should have known that. Exercise, we're on 6.3. I know it's cheating, but I haven't been cheating thus far, so I've only just realised that they're out here. Oh, look at that, rank 3. Rank 2, rank 1. Okay, well, my explanation is however many arrows there are to the right of the 4 all. That's kind of how I'd explain it. It feels like that's right. We'll probably have to find something where it is wrong, where that analogy doesn't work. But yeah, if you look, so that's is rank 1. The second one is rank 2, and the third one is rank 0. Believe it or not, this is a real type signature we had to write back in the bad old days before monad lift IO. Oh, look at this. Does anyone want some free viewers? You got ready? Click it. Too late. I've deleted it. I like some free viewers. I don't know what you... I mean, yeah. Society. Chasing those numbers. No, stop cheating. Right, back to page 72 we were on, weren't we? 69, 67, 70. No, we were way more. 79. I'm just reading random numbers. 79, yep. Okay. Okay. Count the number of arrows. Well, yeah, it didn't quite say that, did it? It says... it says the rank of the function is simply the number of arrows its deepest for all is to the left of. Its deepest for all is to the left of. That's a bit that threw me. Its deepest for all. Okay. So does it mean, oh, is deepest the most nested, I guess? Yes, okay. And the left of. Yeah. See? So it doesn't say count the number of arrows, I'll have you know. It gives it one where my brain, it feels like one of those trick questions to me, the one that you get in an exam. If Julie's going 20 miles north and Kevin's taken a train 30 minutes before, how far has Julie travelled in 10 centuries? I don't know. Why don't you ask her? She'll know. Sorry. But yeah, you're probably right. The continuation monad. Oh, hello. So, an interesting fact is that the type A and for all are A to R to R are isomorphic. This is witnessed by the following function. All right, let's get some witness. Give me a witness. So we've got A to for all. Oops, what was it? R. Yep, and then we've got function A to R, and then we return an R here. Okay, so we will return, yeah. And then that's an A, and that equals a lambda. Definitely not that one. Callback. Okay, yeah. Oh yeah, because if we look, we return a function, don't we? So that's going to be our callback is an A to R. Yeah, that makes sense. And then we call callback on A, which in itself makes sense. So we're const basically, oh, hence a continuation. It's just past. Oh, thank you. Look at this. What a wonderful wife. Makes me a big maybe a lovely mint tea. Oh, can't get any better than that. Well, unless you don't like mint tea, then yeah, you can. Oh, bye. She's off. No. Meowing at the cat. Meow meow. Oh, here comes a cat. Can you hear that bell? That's a cat. Okay, so we've got that one, and then we'll do run cont. So I guess that's to run the continuation. Oh, hello. So we do run cont, and that does a for all R. No, hold on. Where am I looking at? Yes, R. And then it's A to R to R. And then it returns an A. Okay, that kind of makes sense. Let's have a look at this one. So we give the oh, okay. So it's like backwards, isn't it? Ultimately. And that's all that's going on. So in this scenario, we're going to have to do a let. Yes. Oh, okay. Oh, so we're just using ID. Oh, okay. So literally, just ID. Let me have a little look here. So when we go that way, we return a function. So, yeah, and then the function expects a value of another function of A to R, and then within that, the first value to cont. So, yeah, cont takes an A and it returns a function that expects a function, yes, of A to R. So then to do that, well, we create a lambda, which is going to return our function, and then the first value is going to be this, and then we're going to run A into the callback. Yeah, okay, that makes sense. And then to go the other way, in this scenario, we're going to take that first value is going to be that function, which expects another function, and then returns an A. So if we look at that, we've got the F. So we do a callback. Our callback scenario is just ID. So that's just A to A. So to get it, we do FID. So ID would be, oh, but that's A to R. So I guess that'd be R. So what's this? For all A to A. Okay, maybe it'll explain a little bit more. Intuitively, we understand this as saying that having a value is as good as having a function that will give the value to a callback. So having a value is as good as having given a function that will give the value to a callback. Yeah. Oh, okay. So you can either have the value or you can pass it along and get it from a callback. Yeah. I think that's what it means. Wow. That's hot. Can't drink it yet. Whew. Spend a few minutes looking at cont and run cont to convince yourself you know why these things form an isomorphism. Oh, convince yourself. Well, yeah, it goes from one way to the other. So that's an isomorphism, isn't it? That's literally, that's going, you know, it's like to and from. That'd be like to, and then that'd be from. Okay. It didn't take minutes. That's good. Must be getting better. The type for all R, A, R to R is known as being in a continuation passing style, or more tersely, the CPS. CPS. Isn't that some sort of like government body? CPS. I'm not gonna, but let's do some of this, just in case we need it. So the type for all R, which is that, isn't it? This one. Yep. Is known as being in a continuation passing style, or more tersely as CPS, continuation passing style. Oh, okay. So record that isomorphism are transitive. Okay. Oh god. I've got to remember what transitive. Transitive, a verb, the sense use of a verb, able to take direct object, express implied. Saw in he saw the donkey. The opposite of intransitive. Should just put that. Saw in he saw the donkey. Okay. So if we have an isomorphism, T1 is equal to T2, and another T2 is T3, we must also have we must almost have one from T1 to T3. Yeah. So that's, I guess we get, that's fairly understandable. So yes, if you've got one going from T1 to T2 and then T2 to T3, well, that means that when you combine those two, you can ultimately, you'd have one from T1 to T3, because you're just passing the value from T2 there into that one, into T3. Yeah, since we know that identity is A is equal to A, and that A is equal to for all AR. Oh, is it? So they're equal. Hold on. A to R. Yeah, because I guess, does it? Yeah, it's got to be, because that's going to return us once. Hold on here. Oh no, it's trying to catch me out. I guess it's saying that the A is going to be passed in here. So the result of this is going to be that. But maybe not. Not sure. So we should expect the transitive isomorphism between identity A and CPS. Okay. You proved above. I proved above. Oh, so that and that is that. And then A is equal to for all. Is that what you mean? I proved above? I think that's what you mean. Maybe that means I'm right then. I like being right because it's not often I'm right in this context, especially the learning context. The teaching's fine because then you already know the answer, don't you? But the learning one, whoo. Okay, so we know that identity A is a monad. And that isomorphism preserves type classes. we should expect that CPS also forms a monad. Hold on, I want to remember what this is, the actual terminology or the meaning of CPS. CPS equals that continuation parsing style. I mean, I won't remember it, but I figured if I sort of type it out a little bit, maybe I will. We'll use a new type as something to attach this instance to. Let's do it. I think now it's probably going to make a little bit more sense to me. A equals cont, and then we've got an uncont. Okay, well, yeah, this makes a lot more sense. Oh, okay, yeah. Well, this is like a. What am I doing? R. Yeah. I get it. Okay. Should I put it on? No. I could put it all on one line, couldn't I? Really? No, I'm gonna leave it like that. Exercise. Provide a functor instance for cont. Oh, hlint. Use lots of. Oh, hint. It's because I was doing hlint stuff before I came online. Hint. Use lots of type holes. Oh, don't you worry, I will. So, instance functor of cont, because obviously the A gets eaten up by the functor. We don't need any for all here, do we? Don't think so. So we'd have fmap. Whoops. And then so we'd have an f, and then we'd have the value con a. Okay, and then let's get type hole in. Cool. It wants a cont b. There you go. What have we got in scope? So we've got f, which is an a to b. Oh yeah. Okay. So we've got to like do some. We've got to do some lambdas here. I assume to get another value out. It's going to be my guess. Because if we look, we don't. We need to. So we know we can turn a b here. Oh, hold on. But that's it there. So is it simply... Hold on. No. Other way around? No. Okay. That's close. Because we know that's a type A, and then that takes... Oh, it's just FA. What am I doing? No. Oh, it's... Oh, okay. Oh. Okay. Infinite types. Okay, this is where I've got the problem then. What does... I'm sure it's something like... Okay, let's go like that. Now it wants... Here it wants... I found a hole of BR to R. And the only way we can get... Okay, so this... We've definitely got to do some sort of a... I've got a feeling... Yes, so we're going to have to do something like this. Let's do it like that. We'll call it B. Block. What? I got... No, I've gone the right way, haven't I? Okay, there we go. So B. Surely B's going to be... Oh, B's going to be a B to R. Am I going the wrong way here? Maybe... B to R. No, I'm not going the right way about this, I don't think. Or am I? So found a hole. Oh, we just want an R now. Okay, so we've got an F. Oh, here we go. F to A, so B. Oh yeah, so FB, I think. And that gives us an R. No, nearly. So could match type A with actual type B to R. No. It can't be it. So let's go back to this. I'm using loads of type holes. It wants an R. What gives us an R? B gives us an R. Give us an R. Okay. And then to get to there, we've got an A to B. So you'd think it'd be F. But then we've got no A. There's the A. I feel like we're just not using the A. Which wouldn't be right. So we're never getting the value out. But we do need it. Okay, that was like clutching there. Let's go again. R. R. So B to R. So we want that. Oh, hey, blind coat. I like that. Can you use cont? Uncont. Maybe we need to uncont. Is that what you mean? Sorry, blind coat. I remember now. This is where my brain melted and I stopped last time. Cool. Thanks for the enthusiasm. The cont function above. Yeah, this seems very advanced. Hey, Gaffer. I don't know. Oh, no. I think we're going to get it. Don't worry. Don't worry. Bear witness. I think we need to maybe run uncont. Because cont... Do you think it's accessible? Because that's kind of like... We're creating a type to do this, aren't we? So maybe we need to uncont something. But then if we uncont, don't we want to uncont this as a type itself? Let's have a look. Let's have a look. So we'll call this A. What have we got in scope now? A. A is to cont A. So let's do... Should we like... let's do a let. I know this is terrible, but we'll just do it. So I think if we uncont A in... Oh no, hold on. Give it something. C. There we go. What's C? This might be a magic trick. C is... No. We literally just did it. It's exactly the same as just deconstructing it here, isn't it? Because if you look at C, it's exactly the same. So maybe the cont has got something to do with it. Okay, let's have a look. A is... C is for all R, A, R to R. And we've got A is cont. Yeah. But C's not that at all. Oh, bing! That's annoying. Let's delete that. You wouldn't have heard it, but... Okay, let's try again. Let's try again. Come on. We're going to get it. I've got faith. Or we can just, you know, do a little bit of sneaky... No, I think we should... We'll try for another, you know, couple of minutes. We'll give it a go. Give it a go. I've got a feeling we're sort of... I think... I've got a feeling that this lambda's correct. Because if we look at the type... Okay, let's go like... definitely don't go like that. Oh, okay. Escape, please. Yes. So... Yeah, because we know we're down the right line. Because now we only want to return an R inside of here. But it looks like the only way to get to R is A to B, B to R. But what we don't have is an A. So it's saying that... what's the type of A? A... Oh, look. Hold on. There's some values down here. Oh, look at these. A something. A something. Should we try it? A or B something. It can be A something or B something. I'm going to go with A something. Okay, we're getting closer. And now we want a function of A to R. So A to R. F. Yeah. Oh, why not? Okay. We're getting closer. Well, the other option was to use B, wasn't it? What does B want? That wants B. No, so I'm going to go back with A. A to R. Well, we've got like an A to R, which is F composed with B. I thought it was. Oh, hold on. Or do we need to use this, like you were saying, this cont? F cont or... No, because that's they're two functions. F. Oh, did I do them the wrong way around? Whoa! What did I call you? I called you a cunt with a... Hey, hold on though, a minute, before you sidetrack my pronunciation of cunt. I got this right, without looking. Hey, I'm pretty pleased with myself. Okay, how do we get that? Well, look, I guess to compose it, the type holes helped us all the way. Really. This is why we love type holes. So at that point, okay, so we can rewind. I'm probably going to forget now, but stuff it. Do it again. So here we know we found a hole. So, thanks, Blanco. Yep. Oh, hold on. Oh, I haven't got a way of doing it. What I need is this. I need to set this up as a when I do something successful. I've got like the I'm sad thing when I do things wrong. Obviously, you're going to set that up first because you're more likely to do things wrong. But when you do things right, I need to, not just as a follow, but also need to set it up as... There they are. Yeah, that's what we need. Yes, so we got to here. So we know here, look, we definitely need a function. So that then told me, well, we need some sort of a lambda at this point. And then when we were here, it was like, okay, we need an R. And then the only way to get, if we look at the types down here, it kind of gives us a clue that maybe you could use an A underscore. So if we look at A, that's a value that takes, sorry, that's a function that gives us the R there, but it expects a function that goes A to R. Oh, I should have looked at that a little bit more carefully. It's all in the thank you compiler. Next time, it's like reading. If you're reading a content and then you get to a certain point where you're confused, keep reading on. The answer's probably a bit later. So if you're like coming across a type error, just read a type error properly. Because the A's are confusing. Yeah. That's potentially this bit here. What's confused? The A's. But if you look, it's basically saying it expects its first value. So we know that here we want to return an R, don't we? And we know that the only thing out of what we've got in scope that returns an R is this A. Okay, but the way it returns an R is if you give it a function of A to R. So if you go, okay, well, that returns us an R. So let's go A. And then now it'll say, I found a hole that I want it a function that goes A to R. And because before we were going through this isomorphism transitive stuff, you know, when we can go T1 is equal to T2 and T2 to T3 is the same as T1 to T3. Well, we can basically, when you compose two functions together, T1 and you get T3 back. So we've got a similar scenario here, haven't we? So if we look at the types again, we've got a B, which is B to R. Okay, so that gives us that R of the A to R. But then we've got an F, which is A to B. So we want an A to R, so we just compose F into B. And we go B, compose F. Boom. We got it. I think that's okay. It's not too bad. It's not, I mean, I'm surprised I did it, but okay, well, don't you worry. There's still the applicative and monad to go, so it can only get better or worse. Now I found you. Okay, let's try it. Applicative cont where so the first one's going to be, is it pure in applicative? I don't know. It should just give us a little hint. Forget if it's pure or return. Forget which way around it is. Come on, give us a little hint. Come on, compiler. Well, right, here we go. So it wants pure. It is pure. Okay, I've got it right. And apply. So pure. Oh, I don't think this is right. It's this way. Oops. I'd imagine. cannot construct an infinite type. Is it the other way? No, because you're meant to wrap it round, aren't you? This doesn't feel right. What does it want? Lots of errors. Okay. I thought it was just literally wrapped around. So it wants a cont A. Yeah, that's fine. So we've got an A. Pure equals pure A. Yeah. Yes, I'm typing faster. And then at this point, I thought it'd just be cont A. Because it found a hole for cont A. A's A. And pure is A to cont A. So you'd think it'd just be here, cont A. But then it goes, cannot do an infinite type. Hold on. Is this where... Let's try this. ID. I've got a feeling it needs a... Yeah, look at it. It needs another business, doesn't it? Another business. So we're always returning types. I guess? Yeah, there we go. So now it wants an R. So we've got an A... so it'd be BA. BA Baraka. There we go. Honestly, I love type holes. I wish I'd used them when I like first started and I understood how great they are. I kept trying to work all this stuff out in my head. Which was like, what a terrible idea. 3 years wasted. Just try. I am the compiler. No, you're not. You're definitely not. So we want an F. Apply. And then here we want a cont. Let's go with A again. Let's do a bit of alignment jobby. Okay, here we go. Oh god, this one's not going to be too much fun, I don't think. Or it might be. So we want cont B. Okay, well that's cool. How can we get a B? We've got F. F, which is cont A to B. So do we need to get the value out of... I think we need to do cont F, don't we? First and foremost. Because we don't want to be messing, unconting stuff. There. Okay, so we've got... We want to return a cont B. Now we want to return a function that takes a B to R. Have we got an R? A to R, F. F, A to B, R. Well, this one is going to be fun. Or not. Hold on. We can like step it up a little bit. B. Is this helping us anymore? Okay, we're getting better now. Now we want an R. So we've got something else that does a B. Anything else that does a B? No, damn you. A to B. Oh, okay. No, okay. Oh, hold on. We've got some type holes. We can just like randomly just type these in, I think. It's probably a good idea. So I'd assume you want to do something like this, wouldn't you? Okay, let's do it. Now we've found a hole A to B to R. A to B to R. We've got a B to R. Have we got something that returns a B? No. So maybe it's not a... hold on. What's the other options it gives us? Const. Oh. Yeah. I don't know about this one. This one's going to get me. I've got a feeling. But don't give up yet. Do we need like... hold on. Am I... am I being mad? I don't know. Maybe I'm not. We've got an R now. We want an R. Okay. Maybe I'm doing... Hold on here. I'm following things. And I think we might be getting there. Because look, now we just need an R. And then we've definitely got it. Because we've got an A to B and a B to R. An A to B. Except we haven't got... Where's the A coming from though? That's a problem. We've got R. I just want an R. A to B, B to R. But we're still... Oh no, we are using F here. So... What? Which way? A to B, B to R. But this just wants an R. How are we going to get... Oh, here we go, here we go. Oh, we can pass it a function to F. But we've already done that over here. This feels wrong. Do we need to F again? Oh. Because that takes a function of A to B to R, which is A to B. Wow, okay. I'm not sure about this, but we're going to keep going. A to B to R, which is A to B to... So it's C composed to B. But it expects a function. Okay. Which way around is it? B, C. Ooh. C, B. Oh. Okay, I don't think the F is correct because it feels like the F has already been used here. I don't know why you'd call it twice. Would be my guess. But then here it wants the type hole is R. But we can only do at the moment. We haven't got an A. I don't know how we get this A. Where's this A come from? Hold on, this is of type... No, that's just... I saw an A, I was like, yeah! No, that's not it. That's not it. Okay, so what happens if we do, like, C? No. B? Okay, so what does it want now? A type hole of B. So that's what I thought it'd be, like, dot C. But then it doesn't like it. I feel like we're... No, it's not happy with any sort of composition. Doesn't like it. But around here, it looks like it wants something. How long do you carry on before you sort of like think to yourself, I need to look? What's the limit? Someone answer me. Or, if someone... Okay, maybe it's in types. Keep reading the types again. I'm bemused as to where this A is coming from. How are we going to get the A? A, where are you? Hidden. Hidden amongst us. Oh, some idea. Can I... F map. I want to... I like it. Some idea. Can you use F map? I like that idea. Do you think we need to use F map further along here, maybe? Because that would make more sense. Instead of having F here. I'd probably would feel more inclined to use it here. Except maybe I'm not more inclined. Maybe I'm just totally wrong. No, don't do that, Vince. Okay, so maybe from within the level we were at. Maybe from within here. Ah, still no. Can you use fmap? Fmap returns FA, so it takes an F of A to B. Which is... But we still don't have that F of A. That's the problem, isn't it? Or... Let's have a look. Attempt to fill hole. No, it didn't work. Replace with head. Replace with F. See, but then it's A to B. So a function that takes A to B. So what, we do another function? Hold on here. It feels like I'm doing laying up too many functions. Look at the amount of F's I've got in front. That doesn't seem correct. What, I'm going to do another one? Yeah, okay, that's fine. Yeah, unexpected lambdas, cool. What? An R. Oh. Yeah, no, look, the D and the C is exactly the same anyway. So we can't, though it wants an R at this point. We can get an R? Wow. Well, I felt, like for a moment I was like, yeah, feel pretty good about this. And then Haskell just brings you back down to earth, doesn't it? It's like, no, you're not that good about that. Don't feel that good. Oh, I feel like I'm close. Look at the type again. At this, from here, it wants R. But are we nesting too many? Do we need to nest that many? That's what I'm thinking. Let's go back one. Here, again, it wants an R. So maybe around here we want to do something. How do we get an R? Hold on, doesn't feel right. Feels like the compiler's braining out a little bit. What about a gaffer? At this point? A B.C. Yeah, I think I tried that from memory. B. Hold on, we're missing the C. Okay, so yeah, when I had this, so when I had C, I'm pretty sure I did the B.C. Yeah, look, it gives us that infinite type thing. With the A in front. Oh. What? Let's go back. What's the A? Oh, maybe I was dead close. I like it. Thanks, Gaffer. You killed it. That's good. Okay. Let's have a look. A. So that takes that and returns. So we know here we want that function. That's what threw me. So I guess I found a hole for that. So, oh, hold on. That's just giving us the function we want. So let's get rid of this BC. And at this point, it wanted an R. So the only two things that return us are. So we already used the F. So I'd guess, yeah, I should have really just gone with A. And then at that point, I'm pretty sure I did this far. And then we want an A to R. Ah, damn it. I was so close. Yeah, so if we look, we want A, C, so we want B composed with C. Because if we look, we've got B that goes B to R. Oh, yes, sorry, C, which is A to B. So we want an A to R. So if we compose C to B, yeah, then we get the R, A to R. Oh, damn. I'm going to go with 70% there, maybe. I wasn't, sure of myself with that one. But don't worry, we can fail again with a monad. Okay. Isn't it fun? So we're going to go nomad, monad of cont, where, and, well, okay, well, we know this one. It's just pure. We can just do that dead quick. And then the next one, whoops. So we want that to be, let's just, I need another cont, won't I? So cont A F. I'd assume we need to, do we need to grab the F out? Let's have a look. F is A to cont B. No, okay, that's not too bad. Hold on, isn't the monad going to be easier? That'd be great. Because then I guess, let's have a look. So now we want a cont B. And the only way we can do that, typically, no, it's not going to be easy. Yeah, I need to do something with the F. Because, no, hold on, because F is cool, it just needs an A. So type, so we know we need some sort, okay. But do we need it at this level? Okay, so now we need a type hole of A. But all we've got, we haven't got anything that does A right now, per se. So let's do some of this. See what happens now. No, it's not happy. Okay, that makes sense. So we can't just have a random lambda. It doesn't ask for it, does it? Maybe I need to get the F out. Should we try that? Though I thought it was just an F. Do you reckon it's just simple FA? What? Lies. Found a hole for A. Oh, because for all R, A to R to R is the same as A. Why doesn't it tell us that then? It's back to this bit, isn't it? Here, that one. Well, that doesn't half throw you, does it? Maybe we need to understand this. Yeah, this was far easier. No, hold on, it didn't work. It didn't work. It didn't work. Okay. That's. I feel better now. Whew. Yeah, we felt clever then for a second, didn't we, eh? But we're not. No. Okay. I feel better about that. Sorry, Gaffer. We still need an A here. Yeah, let's blame the compiler. I don't think I'm. You know. Can you give it? Yeah, I think the compiler's a they. I'm going to give the compiler the status of they. So it's a computer. It's not a he. Oh, is it plural? They tricked us. Yeah, I think it's a better image if you think of a compiler of lots of little people inside going blah, 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 and then going bing. Have some of that. Well, I don't think it shouldn't be that because that feels, yeah, look, it's not going to accept that because it's clearly not what it is. It should be an F. What can you do? Maybe we need to uncon something. No, we don't need to. Oh, come on. I got like the last one we got like an 80% there, and then Gaffer came in to rescue the day. And then this one here is a bit more bemusing. Try lambda. Should I try lambda from, well, not from the get-go, I guess. Right here it wants a cont B. But we've got this F that takes an A to cont B. But then as soon, should we just try lambda like that, you reckon? Okay. Oh, you want to, oh, okay. I'm with you. Let's do some of this. Okay, well, now we want an R. Oh, we're looking a lot better now. We're looking a lot better. I say that. We're going to have to uncont, aren't we? This stuff out of the F is my guess. Well, we need to get the value. I don't know, we don't. Shh. Calm down. It's amazing. I'm getting all excited by myself. You get like a little realization. Well, that was it just then. Just surpassed me. I was like, oh shit, I'm just getting excited. There's no one here. Well, I guess you are. You're on chat. That's good enough. I get help there. Where are we going? So we want an R. And now we've got a B to R. But we've got an A to cont B. Does it feel... Do we want to go like an extra... Should we go like an extra... Hold on, we just want an R. This is... Yeah, that F is the thing that's throwing us. So I guess if we can get the value out of A to cont B, then we've got access to that B to give to the... Do you reckon we'd go another one deep? I don't know. Okay, it seems happy. Let's keep going. Okay, so this one now wants... The first one wants to be... I mean, it's just totally lost wherever we are. Here, it wants to... Found a hole of P0, T0, R. Oh, things are breaking badly down here. Breaking badly. Which second hole? Hole here. First hole. I don't think we need to nest another one. I think I'm going maybe too far. There, look, because now we got... Well, we've got P0. That's our C. But I guess what can we do with P0? No, nothing kind of like wants it. I don't want your P0. Yeah, I think I've gone too far. I don't know. I don't think... It doesn't feel like we should go another one. I suppose this will work for applicative. Yeah, it will. Lift A2. Oh, yeah, that's a clever one. I like it. Conf F, conf V, so it's lift A2 ID. Oh, yeah. I guess, yeah, that's probably how it's implemented in real life. But I'm still kind of stuck here. Let's go. Should I try it, actually? Come on, hold on. Let's... Yeah, I'm going to try it for your benefit, Haskell. Con F. And what do you call the other one? Cont V. Whoops. Cont V. Okay, and then you're saying lift A2. Yeah. Oh. Have I even got it in? Oh no. Well, I don't have it in scope. Oh, give me the option though, surely. There we go. Import. We'll bring it from there. Oh, okay. Which ID is it not bringing the right ID? Oh, did I give it the wrong? Is it Cont V? Oh no. Oh, sorry, I didn't spot this too. There we go. Yeah, it works. Cool. That's nice. I mean, it's certainly a lot clearer. Let's have a look. Oh, hold on. So, lift A2, yes, it takes a function expects two values, an FA and FB, and returns an FC. So, ID expects two values. Yep. And then... Oh, so what are they? A, B, and it returns us a C. Okay. A... Oh, hold on. What do you mean? ID expects two values. What am I on about? No, it expects one. Oh, is this because the way it's... Let me have a look. FAFB. Well, this is our FA, so we've got to type of that. Yeah, F of a function. Oh, that's our A. Oh, okay, yeah, okay. It's because of the way it gets passed along. Then it becomes 1. Oh, cool, that's clever. That's clever. I don't know why it does that, it's annoying. Just go away. We're still stuck on this though. Haskell, you've not worked this, well you probably do know this one. We need an R. R, like the pirate. And then the only way we can get an R is that B. B takes a B. And then we've got F that returns a cont B. So can't we do F? This feels like it needs... Maybe this is the F map. No. We need to get out of the result of... Yeah, because we need to get... We basically need to get to the end of there. I mean, we could F map to get to that. But I don't know because we never kind of like give it an A. And we did do some... magic. Here it's kind of saying... Should we try... Let's just follow the types, I guess. It gave us that as a little... Here you go, have some of that. But now it's not really helping us, is it? You've not helped us here, have you? What, so you reckon an A? I don't think you're right. Yeah, of course you're not. Oh, okay. It's getting there. It wants an A to B now. What? A to B. No, okay, well, I don't think that's going the right way. But what happens if we do this? No, that's not right. So what happens if we do this? That's not happy. I don't know. I'm going to... Okay, sorry. I've got to have a look. My patience has gotten the better of me. I guess if we look and then we work it out, then we won't feel so bad. 80. Oh, I don't like it when you do this. I feel like I should have tried a bit harder. Where's the answers, please? Solutions. Am I... Should I... Oh, yeah, you like being... It's like being bad, isn't it? Okay, here we are. Let's go back up. Go back up. Back up. Don't see them all. What did we do? Oh, well, we went this way. We didn't go with the lift 2. So that's okay. Feel a bit better about this. Okay, let's have a little look at the sneaky... Okay. If we do like this, then we're not... Technically, we're not quite cheating. Okay, so we've got... Let's use the... Let's name it the same. Maybe it'll make us feel better. Okay, so if we go with C... Not CD, C. So we've got that far. Don't peek. Ah, but look! Right there. Can you see it? Right at the bottom. I've not peeked though, so... I guess I feel better I've got to this. Ah. I bet it's just stare at... Okay. We can carry on. We'll try. R. We want an R. Where can we... We know we can get an R from this C. And then we need to get a value. So do we need to do a do block? Can we do do blocks? No, what have I done? Don't look. Close your eyes. I've got to look up. Look up. Okay, I didn't look. Where was it? That's good. I didn't look. There we go. We're there. Whew, nearly cheated. I guess we don't use the M, do we? A to R. A to R. Well, we've kind of got an A to R for here, but we need to get the value out of cont to then put it into... So that'd be my idea. So I think we need an M of something. Yes. Now we want an A to R. We're getting closer. Okay. And this is the tricky bit. This is why I feel like it needs to be in a do block. Because I guess you could just do... we could just have like that. And then we can just do... get the value out of... Where is it? I don't know what's going to happen here. Well, first and foremost... I could probably just pop that up there. Oh, yeah, it's not going to be happy. Why are you not happy? Because... No. Oh. I guess I'm trying... How can I just grab it? It's not the way to do it, Vince. But we know if we do F something... Wasn't that... Oh, sorry. M. So maybe I need to do the do here. Yeah, okay, let's try that. I thought I could do it from within, but... Okay, where? Getting closer. So now we need an A to R. A to R. What have we got in scope? We've got a C and an F. A cont B. That's close. So now we just want to get the B out of F. Yes. We just want to pass this along. A to R. A. Where's the A though? F, A. What? Have we used the F yet? No, we haven't. Okay, so this is not really... A to R. Read it. A. So we want... There's the F. But the problem is, how do we get the value out of F? See, it's not right. So we need to do like oh, I can't do it. Oh, it's the result of that though that we want to grab out. Oh, I was on the right line, I think. I think. So do, and then we want to go. Let's keep going. There. Whoops. F, and then here we want to. Yeah, let's keep going and let uncont that. Okay, we're getting there. A to R. Christ. So we've got G now. We've got a G value, and I'm guessing what's the type of G? Show us the type of G. G is BR to R. Oh, maybe I haven't got what we want. A to R. A. What's the typo? A to R. Sugar. It's not quite right. Maybe it is a sort of an F map. But it's on the return. That's the bit that's throwing me. How do we F map on the return? Oh, oh, hold on then. Hold on. Let me think about this a little bit more. What's G giving us? G's just giving us whatever the inner value, which I feel we need. Oh, but look, the answer's right here on the right. And I'm still at A to R, which is what we were when we, you know, if we go here, I don't feel like I've gotten any more. So at this point, we still need A to R, don't we? So I don't feel like we've got potentially any further by doing this do block. So, no, we don't want to do another. So, okay. Something. And then maybe F. Okay. We're getting closer. Cont B to R. We've got that, haven't we? We've got F. Oh no. Ugh. Damn you. Cont B to R. Oh, hold on. We'll probably have the cont B if we have a lambda. We'll just call it con. No, co. What's co? Cont B! Boom! So now we want an R. Which, I can't remember. Oh, yes. So now we want to get... Okay, in here, look. Okay. So we can get the value out of co and then pass it to B. And then that'll be our R. Is that right? Feels right. Should we do it in a do? Whoa, it's not going to look very nice. I'm sure there's a nicer way to write this. But if we work it out first, and then we'll try and clean it up. So we can do co. Oh, and to get our B. No, we probably don't need to do in a do at all. What am I talking about? Don't do that. Yeah, we can do it from within in here. So we can uncont. Co. We'll have some of that, some of here. There we go. And now we want the type. Found a hole of something else which I wasn't expecting. Damn. Was it run cont? Was that the other one? What do we have? We had uncont. We're kind of on that run cont, which is the other way. Oh, go away, go away. Okay. Oh, I'm so close. It's in here now. Okay. Found hole. That to R. I thought that... So do we need to F map again to get to the B? I guess we do. Yeah, so it's F map C co. I'm doing 2 F maps. Oh no, yeah, I didn't think so. Yeah, that makes sense. What will it give us here? Okay, so cont B to R. Do we have that anywhere? Oh no. God damn it. Well, we've got cont B there. Okay, so cont B to R is C co. What? Cont B. We're still not using the F though. Oh no, we are right at the end. I'm going to have to peek. Haskell. I'm going to have to. I feel like I've... What if I peek one line? Then that's kind of like... Oh, I feel bad if I do though. But then I'm going to have to... It's okay. If you're watching this on YouTube, you won't see this bit. I'll just get to get to the answer. This is how I got there. Woo, there you go. So cont B to R, but that's the bit that I'm struggling. So we've got cont B here. So it's just a function. So we need to return a function of cont B to R. Well, inside of here. Sorry, we need to have a function that accepts a cont B to R. And the only R we've got, what aren't we using? We're not using a C. Yeah, this is like the... So, okay, this was my other thinking. And here, we need a B. And we need to get the value out of cont. So I thought you could just... See, I thought you could do that. But you can't. How do we get this B? B, come out. Just come out of cont. Maybe I do need a do block. Let's find out what the B is. I tried on cont, yeah. So I did that, and then I did on cont co. Get rid of that. Oh, damn it! Go back. Oh no. Okay, it's fine. I thought no, it doesn't work. Yes, okay. So it's not after all. It's not happy because uncont doesn't actually. You'd think, I don't know. Does it returns just a function? Oh. So maybe we do need a do. Do. Then we want to do something here. Whoa, what's going on here? CA to ABC uncont return ID. So you're not even grabbing. You just got fed up with me, didn't you? So Haskell was like, screw this guy. Been giving the answer straight up. But Are you sure? Doesn't feel right. I'll try it. Oh, you're not sure about it? Oh, that's good. You might be right though. I mean, I didn't realise that... Yeah, it's fine. But I didn't realise you could still apply inside, which is kind of what I was trying to do. But I guess maybe because I'm bemused by how this... Oh, so it returns this... if we look at it, when it's applied, so it's like it takes a cont of cont b. So how can we make ours work then? I was fairly close. I think it's because I've taken this m out. And maybe here I need to... This is where I need to like... Shit the bed. I'm going to look at the answer. It's on the next page anyway. Hold on, I did... oh, how close were we? Well, this clearly works. We'll work that out why that works. How far did we get? So we got... Yeah, so I just went the wrong way. Went the wrong way. We didn't want to do an F map. Yeah, I think so. Maybe, yeah. Yeah, that's what I did wrong. I just... except we don't want to... Let's get rid of this stuff. Let's bring that in. Sort of. Let's bring up... What was it here? So, A. I don't... Oh, so I guess it'd be an A by this point. Okay. Yeah. And we don't need these parens around here. And then from here, yeah, this is a bit that threw me because it wants an R and you're just like, how the hell do you get an R? But I guess there's that M does that. No, it doesn't at this point. We don't want... So what's the value of A? Value of A is A. Oof. So FA would return us a cont B. Oh, sorry, an A to cont B. And why applying C to it? B to R. FA would be... Oh, my goodness. No, where's the C coming from? Cont. Oh, hold on, look. C. I don't want this M though, do I? This M's just coming from nowhere. I've put it too early. No, I haven't. It's exactly the same. Cont. C. And then I've got an M. Yep. And then I've got A. And then here, oh, I've got an uncont. Okay, that's where it threw me. But why an uncont? Oh, damn it. It's like close, but not close enough. Found a hole. Cont B, B to R, and R. So if we look at the type of... Oh, I guess it doesn't show us. Does it give us like a type hole you could fill it with? No. So that's the one that threw us. Attempt to fill hole. What does it do? Oh, it kind of... So uncont makes F. A to B, sort of. I guess. I think so. But it's uncont. Maybe that's a bit that's totally throwing me. Yeah, this one. Mind melter. Because we know that here. Let's have a look. Because I guess we can get a clue from here, can't we? If we do this. Whoops. So we want that to be cont. So it's got to it's got to return a cont of something, which is what. Yeah. So it's got to return us a cont of something, which seems weird when you look at the uncont of the type. Oh, I guess the R would be the cont of something. Okay, so whatever we pass to uncont, it'd be a function that accepts that to that and then returns that. So I guess with uncont we could make, to get the R, which is whatever we'd make it, so we can use it, so we can start off with, I guess this is why this way is pretty good, because we kind of like from the get-go we use uncont. But this way, we use the uncont after digging in. But what are we digging into? That's what I think of this. Whew. Yeah, it'd be good to get explanations on this as to why. Because the bit I'm not looking forward, exercise 6. I mean, I don't think I'm even gonna. I'm not going to attempt to mode a transform. Oh, I might do. Why? Let's try and understand it. So we've got a cont, and then we need to. So when we do cont, let's break it down. So we go like that. So we know, and then at this point, it wants a function that b to r to r, b to r, which is kind of like similar to that already, isn't it? So from this point, okay, well, let's give it a function. We'll call that, what was it, C, wasn't it? And then here, so it was a b to r, a b to r, and then so a function from b to r. So now r is original, so type hole r is expected for all r, so we need that. So now we need an r altogether. But this is the bit that's like super confusing, because we know we've got an m. Okay. Let's look at m. M does. So see, we just want to. Okay, so we just want that back, because that's the only one. Well, I guess the C can do it, but ultimately we have to work out. At some point, we need to. You know, this is a value that we're passing on. So I guess that makes sense here. And then at this point, it says it wants an A to R. Okay, so let's give it an A. So now now we're back to, because this is what's through me. So when you don't do this, first here it says, oh, I just want an R, and then you do this and it says, I want another R, and then you're just like, okay, well, it kind of feels like you're going around in circles, doesn't it? And then at this point, we need to get to this R, which we know, I guess, it's referring to this R, isn't it? Yeah. Which, unfortunately, I guess it doesn't give it as an option, which is probably why it threw us. So I guess at this point, we were kind of like trying to use uncont, weren't we? Yeah, so look, I mean, so straight away you're kind of like, oh, well, hold on, because uncont takes 2 values, doesn't it? No. Yes, it does. So that was the error with that. I should have read that, damn it. Expect to type R with actual type, blah, blah, blah. Okay, so that's why we went wrong. Damn it. God damn it. That's what threw us. So the first value, yeah, that's probably what threw us. the uncont. But hold on, you didn't. Where's uncont up here? Uncont. Yes, 2 values. Look, 1 value, 2 values. Derp. Derp. That's where it came. That's what blew us. This would have been a lot more. Because now we want a cont A0. Well, I guess it can be whatever, cont of something. And we know we can get that by doing... F does a cont something, and then that's... So F, I guess it's just a type just named it. I guess it would be handy if that was being cont B. That would have kind of been, oh, okay, yeah. But you can get around that, can't you? So it's FA is for this one. What are you doing? Why are you freezing? Don't freeze now. No. Oh, no. Maybe I'm past the 2-hour mark. This is when, like, my shit goes down. Ah, boo. Boo. How can I... Yeah, it's not even... Look at that. It's not even loading up. Back, back, back. Yeah, it's dead. It's died. Let's have a look how much it's dying. Not that bad. I can't believe that's 100 Wirecast. You suck. Eating all my CPU. Okay. I don't know if it's going to save this. Probably not. Oh, that's a shame. Hopefully it saved everything we did. I've got a feeling it didn't. I'm just looking now. Fingers crossed. It got... I think it... No, it didn't. That's fine. It got pretty far. We can go back. We can just finish this off. Let's go like this. Well, we'll remember it now anyway, so... What we should do. So yeah, so we were like there, and then here we got uncont, and this is where that threw us. Whoops. Like that, and then we know that that takes that, and then we've got a beta R. So if we check out a beta R, we'll look, see. There we go. That works. What is a type of FA? Oh, sorry, I didn't read your comment then. What is a type of FA? Oh, is that you meant to wrap the FA? So like, what's the type of this? Oh, well, it's I guess it isn't because it's expecting 2 types. But the type of FA would be cont B. Yeah, because F returns cont B. And if you apply it to A, so that's cool. That's cont B. And then the second value, we want to be a function of B to R. A B to R. Yeah, this is what throws me here. This. A function of which is here, sorry. I'm confused as to why this uncont expects 2 values. That's what threw me. I don't get why that type is saying. It looks like it just expects 1 input, returns an output. Sorry, it expects a function and returns something else. But then when running it, it clearly wants 2. If anyone can tell me why, that'd be great. Because I don't know. Because that's what threw me. I was expecting that you'd pass. I mean, even... Oh, it did save the answer here. Even in this scenario, you know, you're passing it ID as the second value. What becomes the ID? Yeah. Does it show us here? So look. Yeah, so it shows what uncont is. And then when we go here, Oh, god damn it. Because, yeah, the first value's got to be cont A. Oh. Yeah, sorry, because it's like a gadget, isn't it? A gadget. Yep. No, you're right, Gaffer. So, but the compiler makes a record into uncont, which expects a cont A and a function, and then returns you an R. So that's what threw us. Well, threw me. I'll say us. I'm trying to like, spread the load of this. Where is it? Spread the load of. Whilst I take a sip. Hold on. I've got to do it right. Oh my goodness. There's the load. There we go. That's like a bit. I guess if we'd have gotten that, then it wouldn't have been so bad. Oh, it's always the simple bits. But let's look at. Oh yeah, and then obviously this will just be C. So in this scenario, there's no. So we're not getting the M out here. We're just using CA. So let's have a look at this. Because this was cool. Thanks, Haskell. I like this one. So let's have a look. So now we've got the CA. So we're using like a bind, aren't we, to get the value. So if we look at our CA, it's cont to A. So we want to get to our A. So that makes sense. So then here we'll grab that value out. And we're going to stick it into, what's this value? This is A to cont B. Okay, so we'll get our value out. So, when we get the C, when we bind out of CA, so if you look at CA, where is it? CA, there's cont A. So when we right bind, we get the A out. Yeah. And then we've got here ABC composed with return. So because we know that it needs to be re-wrapped up, so we pass the A into ABC, and that then creates cont B. Composed. And then does it have to be... Oh, hold on. Sorry. Just looking here. Does it... Yeah, okay. Look at the... I'm just looking at the... Yeah, so you could do replace with those. Look at the other options, though. I don't know about those. So what does it expect this type hole to be? Cont B. Yeah, look. So it needs a cont of cont B, which is exactly what a return would do. We're wrapping it back up, aren't we? Which makes sense. And then when this goes into here, so the result of that would be... Would the result of that be a... oh, sorry. Aside, are those suggestions in blue on the right-hand side HLint? No, they're from the Haskell language server. Which is... Haven't I... I thought I might have shown you that. Oh, hold on then. Why is it switched over there? Okay. Well, you can't see what I'm turning to. Yeah, they're just... Oh, I have shown you. Okay, yeah. But there's like 6s out apparently. There's going to be more cool stuff, but I don't think it's come out in the unstable version of Nix for me. It's not there yet. When did it come out? I want to look actually. Haskell language server. Let's have a look. I don't think it was that long ago. Releases. Like maybe 5 days ago. Oh yeah, so it won't be in Nix yet. Oh, but it attaches, look, integrates HLint diagnosis to let you apply suggestions to fix them. Okay, so you do get another... the ones I was using were coming from Haskell, but it looks like the new one will have HLint there as well. Which is cool, isn't it? So you get more than one recommendations. Module name plugin. Okay. And loads of other cool stuff. Oh look. What did you do? That's what we're working on your book, Sandy. And you're allowing holes filling to deal with recursions. There. Oh, he's been busy on here, eh? Ignore flaky tactic tests. Cool. Okay. So I feel better about that. I think, yeah, I think it would have been nice if... I think it would have been nice if for some reason on cont I remembered that it has to take a cont A and a function, then return us that. So close. Well, the next one though, I definitely don't feel any... where are we? I don't know why it's jumped to that screen all of a sudden. Exercise that. I mean, monad. I guess. Monad transform version of cont. I mean, it's gonna surely complain. Oh, wife's shutting the curtains, I guess. And again, Soza. She's not sorry. Perhaps you meant monad. I mean, oh my god. What page? Oh, hold on. Are we just looking at the answers? Yeah, we are. Oh, what? I was going to... Didn't it say do an instant? What was the... Oh, hold on. I need to get 254. Okay, I need to go back to the actual thing. 70... There. Provide monad instance of conti. We did that. Oh, okay. I'm just jumping. Monad applicative is going to be here. Look, monad transformer version of. Okay, let's go through that, and then I guess if we get to there, yeah, I was going. What do you mean make an instance? I was dead confused then. Right. So we did monad. One of the big values of cont's monad instance is that it allows us to flatten a JavaScript style pyramids of doom. For example, imagine the following function: all perform asynchronous I/O in order to compute their... Yeah, now we've done like the, you know, the mind-boggling part. We can get onto the business part. Get into the business. To compute their values, we will call their given callbacks when completed. Well, this sounds good, doesn't it? I think it sounds good, this, to me. Let's have a look at some examples. So with... I guess this is going to be... there's going to be a bit of pseudo in here. I don't know, I'm not really looking. Double, what is it? R to R? Yeah, that's cool. You going to find it? Ah, thank you. F. That's going to be F 1.0. Okay, and with time... Do we even need to... Okay, let's keep going. With timestamp, that's... Oh, hello. That's going to be int. Okay. I'm going to because I'm like typing and trying to work out what's going on. What am I doing? Oh, I don't know. Oh, with timestamp. With time. Could have written it out. I've said it so there's a bit of a delay purposefully. So I wanted it to... I mean, whatever. Timestamp. That's what we're going to do. And then with OS... Linux, yeah, it's probably a better than what I'm doing right now. Bloody Mac OS. I guess it is on Linux in a way. With OS, and that's going to be another F2 and pass Linux. Okay, we're getting closer. And then release string. We can write a pyramid of doom style function that uses all three callbacks to compute the value. Let's do that. So this is our, we can get rid of all this stuff here. We can get rid of that because that's not being used. Oh, I thought it was being used. Oh no, did it just grab it from, hold on a second. Oh, it's not being used because I've just commented it out here. Okay, that makes sense. No, yes, right here. So next one, release string, real lease string. Okay, and that's going to be of type. Yeah, I think I get to a mark from doing these. I get to about the 2-hour mark, and then brain just starts going like that. So with version number, and then we want to do a. Oh, this is going to be horrible, isn't it? Version, and that gives us a function with timestamp, and that's going to give us a function that returns date, and then you want to go right underneath, thank you, with OS or okay, yeah, that's fine, and that's going to be OS, and then yeah, go under there, thanks. So we do want to do OS plus whoops, we want to do, whoa, hello, why do you, I have had to check then, things was going mental. Plus plus show the version. Why can't it? Look at that, it should just show me it, but guess it didn't. Plus plus, we're going to do another one of these, and show date. Yep, should be happy. Let's just refresh Haskell language server. I bet people that are on like VS Code have like a really nice journey of Haskell language server, and they can just, you know, continuously use it. But me being on Emacs and or Doom specifically, I feel like I get a bit of a, I have to keep refreshing it, which I've got a feeling is more related to this. Yeah, you're on that vibe as well, I think. But I don't want to do VS Code, so sorry VS Code. Right. So indent the code. Indented this code becomes. I'll go. Notice how deeper the callbacks go, the further indented this code becomes. We can instead use a cont or contt if we want to believe these functions are actually performing I/O to flatten this pyramid. Let's do it. So we'll do a release string cont. Let's have a look how this we'll make it strong. We'll spell it wrong again and again. Okay. And this one, oh, okay, so run cont. So we've got the function run cont. Oh. And then uncont. I guess you have to do that little. Why do you unwrap it and rewrap it? We'll find out. Especially when you just type the wrong stuff. Run cont, sorry, it's right up here. So it's for all R, A to R. So it's a function. So you can see how that's, you know, when we're doing the for all on the left or the right. So the callee will be able to, from within here we can tell. Is there something like that? Yeah. So from within here we're passing along what this is going to be. So it's a function that is a function. Yeah, so basically it's like, you know, it's a function within a function. And then blah, blah, blah. So we'll see how it works from within here. What I'll do is I'll type them out actually, and then we'll try and break it down. Timestamp. Try aligning. So I've got a feeling we can work it out fairly easily. I've got a feeling, ooh, that tonight. Oh God, that song's so bad. Why is it in my? What? Is it capital O? Did I do it capital O? Yeah, I did. Totally ignore what just happened then. I don't know. Sometimes I get the urge to just sing shit songs, and that was one of those times. So we're doing exactly the same thing, except we're returning pure. But then I kind of wonder, oh, we need to return pure. Oh, that's why, because we're inside the monad. And then we need to return pure, so we need to get the value. So we uncont to get the, because my assumptions is here it'd be like cont of cont string, and then we uncont it to get cont string, and then we run cont to get the value out of. So then we just get string. That would be my guess. We'll soon see how good my guess is. Show version. What are we doing next? Oh yeah, sorry. Another dash, and then we'll do another show date. Date. Yeah. Okay. So that seems to work. Let me just restart Haskell language server just to make us feel better. So when written, uncons is like 1 level deep. Runcon is like 2 levels deep. I think the return of this here, I'm fairly sure that because it's pure, so it'll be, oh no, sorry, it'll be, yeah, I think, yeah, so uncont, because I guess, oh, so if we think of uncont, we're only passing it the cont A, aren't we? Because we know that uncont, look, if we look at the type, when it shows, come on uncont, show us the type. Okay, well, anyway, so we know that the uncont, no, it's gone. What's not happy? Be happy. Do. And it doesn't help that I sing on top of music. Error. Okay, there we go. With OS lacks a binding. Whoa, what do you mean? Of course it does, because I like that it picked it up now. Look at all the typos. Now it's deciding to tell us. Version. No one jumped out and told me all these mistakes. What sort of H-lint am I getting here? Okay, so if we look at this is why it was nothing. So that expects cont A and a function of A to, or for all R, A to R, and then returns us an R. So uncont. So that yeah. So technically, oh, and in this scenario, oh, here we go. Oh, look at that friggin' heck. This is why the Haskell language server is cool. So now we've got it with the type holes filled in. Sorry, with the, you know, the A's filled in. So in our scenario, we are passing it a cont of string, which is what I thought. And then, so yeah, at that point, but we know that uncont expects 2 values. So the second value, so it's now it's kind of become a function that expects this at that point. Yeah. Okay. Yes, I guess from here the type would be for all R string to R, and then we've given it that. So yeah, so it'd just be a value from this to this to, and then does run const do the opposite? Run const, yes, it gets that value out to string, which just feels a bit unintuitive when you look at the type, doesn't it? So I guess you're expecting an R, but really you get back a string, which is what makes it weird. But if we look, we're running the function with a callback. Well, sorry, with the ID. So we're just saying run this function, which is what in our scenario? This function. Okay. So it'd be to get, can we press on here? Yes, okay, so, oh no, we can't. I thought at this point it shows us, no it does. Doesn't it down here? What the type is on the right hand side? Yeah, it does. So if you look from here, uncont, the type before, everything after the dollar, this is the type of it. Yes, like I said, it's a function that's expecting this big function in a return us. Whoa, look at the size of that. So I guess that's why it needs to get all that value out. Who knows? That's some complex types, isn't it? Let's be honest. It's not so bad when you see it like that, and then it's not so bad when you see it like that. But ideally, I think it's ultimately at this point you'd feel like I don't know what you feel like, because this is ultimately because uncont expects two values, doesn't it? And at this point it's clearly that it's like it's a function from something to this uncont, so we're still expecting that value, and then here it like ignores that value, doesn't it? So it's how to pass it that value. Oh, okay, so run const passes the continuation, which is that bit, to an A. So we're passing, when we're calling it to that, oh my goodness, brain gone. I think if you remember to uncont and run const, it makes sense. But it's really hard to explain, I think. I've gone into this, it's really hard to explain scenario. Let's see if we get more intuition. Oh, okay, well we're on this mono transformer part version of const implement it. Yeah, I mean, we'll look at it because I'm not going to implement that. I guess it wasn't too bad, was it? It's down here somewhere. What chapter are we on? Oh, there it is. New type. Oh. Yeah, I don't think I would have got this. Not at this time. Cont t ma. Okay. Equals cont t. Oh my goodness, yeah, because it's going to be the same, but with it's going to have a wrapper, isn't it? Because mono transforms just. Oh, well, I could have probably got close, to be honest. Oh, okay. What was it? Uncont. T. So if we look at cont t there, look. So if we look at the stuff, we're basically, it's exactly the same, except there's an M here. Ultimately, look, we're just, because we're dealing with monads, there's got to be an M. The M for the monad. Monado. Okay. And what does it say below? The functor applicative and monad instances for cont t are identical to cont. Oh, okay. Oh, so you can just reuse it. Nice. Or not, they're just the same. I think that's fine. Yeah, it would be nice to get a deeper. So I think where this becomes struggling is because we're not passing around values and stuff. We're sort of passing around functions, aren't we? And because it's a continuation, I think maybe all generics. Bloody hell. Where are we? 6? Here we go. Extensional types. Yeah, it'd be nice to get just to get like a little bit more in depth as to what run cont and uncont is all about, because it mentions it obviously here. Look. So an interesting fact, and for all are A, and for all are isomorphic. Yeah, so that's a bit that just throws me. I think the main thing here that's throwing me is that. It's a function that takes an A to R and an R. But this is, the whole of this is, look, is up here. A cont A, a function, and an R. Yeah. It's an A to R. So whatever our function does, it would pass as an A to R. So FA, A to R. So for all is, so for all R, A to R is referred to as continuation. Yeah, it's this continuation passing style. Maybe we need to read up about that. It's like, yeah, because I guess, you know, here we're kind of like doing that where this was like the first port. Oh, sorry, here was the first protocol where we're doing that continuation. You know, so we've got an F A to B, and then we've got a B to R. So we're able to make an A to R, which makes sense. Yeah, I think the confusing thing is this is all passing callbacks around with types, and that's what's potentially like the most confusing things. Is that's what's happening. We're so with here with version number. So we have to wrap the result of, because everything takes a function. That's what's like freaky. So look, so whatever the functions are. Oh goodness! So it's a double to R. And but where? Oh my god! So I think it's passing everything up with version number, cont, continuation. But does it mean that it takes? What ends up being these F's though? So I guess is the question. How is it? It's implemented here. Yeah, because this is the thing. It's passing along lambdas. Whoops. But that just returns string. So I guess how I see it is continuation passing style is the essence of higher order functions in JavaScript. Imagine like using map, reduce, filter. No, I think it's a little bit, sort of, but I think it's a little bit beyond that. I think it's, because you know, because you can kind of do that with composing here. So what you're saying is more like composition, I think. So, you know, you're able to do one thing, pass the result into another, and you kind of also do that, you know, when you're doing, blah, 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 you know, when you're doing bind, you essentially, you know, you pass one result into another function. But here's like probably a bit better. In a nested manner. Yeah, you can still, oh, maybe. The confusing thing is this would just return string. I guess it's because what's another thing that's maybe throwing it is these are then static, and we're probably used to seeing something. We could maybe follow it along and see where a string to R to R. So there's our string to R. So with OS. Yeah, I think you might be right actually, because it looks like there's our string with OS. Let's have a look. With OS expects a function of string to R. So there's our function of string. So we make it a string here to R. Oh, stop jumping. To R. So we've got a function of string to R. So that's a string. Okay, to R. Yes, and then we've got a timestamp, which is another function int to R. Another function int, and I guess because the result of that is R. Yeah, okay, yeah. I think you're right. So it's the ability to just nest things. But when you use cont, you don't need to do this nesting. You can just wrap it round, and then you're passing along. Yeah, I don't know. You're passing along stuff. Oh, it's because of the bind. Because of the bind. Yeah. So look what the type of version is here. Ah, so that's just double. So when you left bind a cont, which is... How can we see what this value to the right is here? So I guess it would be a cont of a function expects saf, and then that just returns us a double. So we're binding out and getting the value out of cont of whatever this function is. Then we get the... Oh my goodness. Yeah, it's a bit of a... Might have... Yeah, maybe I might ask some questions on the Slack. So I'm going to go offline, have some food, and look at this and see if I can get a better intuition as to what's happening. Sweet! Okay, well, thank you for joining. I'll do a bit of this, look. Maybe I can just do outros like this. No, I can't really. Do some of that. And I shall say... Oh, I said tomorrow, isn't it? Yeah. So I shall see people if they come along tomorrow. Thanks for joining. Yeah, have a good evening. See you later.